Yeah, good morning, one and all. In this session, we are going to discuss about timing diagrams of 8086, or we call it as system timing diagrams. And of course, 8086 is available in two modes, calling it as a minimum mode and maximum mode. Minimum mode for single processor and maximum mode for multi-processor. Okay, so let me see its operation based on the timing diagrams or system timing diagrams. Okay, first of all, we'll look through the system minimum mode system. If you observe this system, so this is the diagram in which the microprocessor 8086 is connected in minimum mode. If you observe this entire diagram, this is the 8086 connected in minimum mode. Of course, you know about the clock generated, which is going to generate reset clock and ready. It contains all these. So this is made with 8284. This is actually externally connected to this, and which is operated by crystal oscillator. Okay, anyhow, other than that, see for operating a microprocessor, we generally require the memory from where the data is going to be accessed and can be computed by the microprocessor, and after that it may again send back to the memory. So here the memory we are taking here RAM and ROM, and other than RAM and ROM, we're also having one more module calling it as IO. So with these three peripherals, with these three modules, the CPU has to do some transaction. So to undergo that, the CPU must have three types of buses. One is calling it as address bus, other one is calling it as controlling bus, other one is calling it as data bus. Data, address, and control bus. Yeah. So first of all, we know that the address, we have AD0 to AD15, which is multiplexing of address and data, and A16 to A19, which is multiplexing with the some status signals. So we have all these. So from these, we need to separate address bus, and then the data bus. Yeah. So these all address and data status lines are given here, given to the latches, and these latches are going to be controlled by the ALE, address latch enable. So whenever address latch enable is given, these latches are going to get address from all this stuff. That's why you can see here A0 to A19. So 20-bit address is generated by using the latches. So about 2 to 3 latches which are required by here to get A0 to A9. Yeah. Now coming to transceivers. The transceivers are going to give you the data bus. Just like these are giving address bus, these are going to generate the data bus. And other than these, it is also controlled by data enable and data transmit and receiver, because these two are generally controlling the transceiver, whether to transmit or to receive, and to maintain to make the transceiver which at which time the data is to be enabled. Yeah, this transceiver is generating the data bus D0 to D15, totally 16-bit data. So in this way, address bus is separated here and data bus is separated here and is applied to all the peripherals. And for the as we are working in minimum mode, so the input output ports may be few, hence here we are not addressing the IO. If many number of IOs are there, we need to address. If a minimum number of IOs are there, there is no need to address. Directly we can operate on IO. Yeah. Yeah. Other than the data and address bus, we require the controlling also. Like we need to enable these peripherals and we need to say that we need to read the data from it, and we need to write the data into it. So this all controlling has to be done. So for that, you are having two more modules. One is calling it as demultiplexer. Demultiplexer takes inputs from M/IO bar, RD bar, and the WR bar. So because of these three inputs, it is going to get four outputs: MRD, MWR, IORD, IOWR. Nothing but memory read, memory write, IO read, IO write. So these are the four controlling signals that you can observe here: memory read, memory write, memory read, IO read, IO write. As this is ROM, we are not having memory write. That thing you know. This is IO read, IOR. So these all controlling signals come from this. Other than this, for enabling these chips or these modules, so we are getting from here. This takes inputs from BHE bar. Other one is A naught. So A naught and BHE bar are used to get these controlling signals. CSE, nothing but chip select RAM even bank, chip select odd bank RAM, chip select even bank ROM, chip select odd bank ROM. So each memory is divided into two parts: odd memory and even memory, odd bank and even bank. For each, we are having each enable pin. So in this way, controlling signals are generated, address and data signals are generated. So because of all these, you can have the transaction with the peripherals by the CPU. So this is the diagram for minimum mode. Let me see with the help of timing diagrams how the operation can be done. First of all, we'll see read cycle timing diagram for minimum mode. Read cycle minimum diagram. Okay. So first of all, the foremost thing is we require the clock. Based on the clock only, all peripherals along with the CPU are going to be worked, because we should have some synchronism. We should have some control on all peripherals that can be done by the clock. Based on the clock, all activities are going to be done. Yeah. So generally, there is a term calling it as machine cycle. Machine cycle, it may be of a 4 plus 1 cycle. So to complete one instruction execution. So here also you can observe T1, T2, T3, TW and T4, totally 4 plus TW, nothing but waiting cycle. Whenever time is not adjusted, these cycles can also be added. So within this cycle, one operation can be executed generally. Yeah, this is the clock, and followed by, so after getting the clock, we require the address. So here we are doing what? Reading. So we are reading from either memory or from IO. So we need to know from which memory location we are reading, from which IO port we are reading. So that can be done by getting the address. Before getting the address, that address is mixed with the data or status, so it is to be separated. So and hence here we have raised the ALE for one cycle, T1 cycle. So in this cycle, the address is going to be separated. If you observe here, from address and status, address is separated A19 to A16. From address and data, address is separated A15 to A19, A15 to A0. In this way, A0 to A19 address is available now. Now we got the address. After getting the address, so after getting the address, so we need to make that device enable for reading, enable for reading. So and hence here we are using a RD bar, nothing but read. So this is active low signal, and hence we are making a low. At this time only the data can be enabled, the data can be readable. At the same time, as we are using a transceiver, so what that transceiver should be in the receiving mode, then only the data can be readable. Therefore dt slash r bar is also in a active low, hence it should be also in low. And one more thing, den bar, nothing but data enable. Even though rd bar is low and dt slash r bar is low, still if you don't make dn bar low, the data cannot be validated, and hence this is going to be make low to validate the data. So in this way, the data can be read in this cycles from T2 to T4. In T1, address is there, and T2 to T4 data is there, data bus is available, and through the data bus, the data can be read by the CPU. So this is a read cycle and timing diagram for minimum mode. Similarly, the write cycle timing diagram for minimum mode. The only one difference you can observe with respect to the read cycle is instead of RD bar, you are having a WR bar, and a DN bar is same and same waveform, and whereas a DTR bar, earlier it is in low, now it is in high because DT slash R bar. So writing nothing but we need allow to transmit the data. We need allow to transmit the data by the transceiver. Therefore, this is going to be high. The remaining are same to same. I hope you understood this. So these are about system timing diagrams in minimum mode. Let we go to the maximum mode. So this is the maximum mode diagram. That is a maximum mode system diagram. And if you compare with the minimum diagram, so up to this part, other than this 8288 bus controller, almost everything is same except 8288 bus controller. So because 8 maximum mode will be working with the other processors, therefore there is going to be a bus control. Based on bus control, the bus can be allocated for various processors along with the 8086. Yeah, so just like in minimum mode, we need to have the address, and we need to have the data, and we need to have the controlling signals. So just like that, here address and data status stuff is given here. The latches are getting releasing address and giving to RAM, ROM, and IO, and the data buffers are transceivers releasing the data bus and giving to RAM, ROM, and IO, and CS logic is giving controlling signals for enabling, and which are giving here. And instead of DMUX there, here we're having 8288 bus controller. This bus controller is releasing these reading, writing controls which are given here. And one more thing, the bus controller is now controlling some of the things. ALE, DAN, DTR bar are now provided by 8288. Earlier, it is provided by this. Now, these are provided by this. Means in maximum mode, there is some control even by the bus controller rather than the microprocessor itself. Yeah, so this is about the timing maximum mode system diagram, which is in comparison with the minimum mode. Let me go through the timing diagrams. If you observe these timing diagrams in maximum mode, this is the read cycle. So just like that, in T1 cycle, ALE is enabled, and other than that, we require status S2, S1, S0. So based on our requirement, so this is going to be in one condition. So we have eight combination. In eight combination, one combination is memory read, other one is memory write, other one is IO read, and other one is IO write, and some other options are there. So based on your requirement, this is to be in that combination. Yeah, and at the time of ALE, the address is came out from this and this bus, and after getting the address, now the time for data, for reading the data from memory. So we need to make a memory read control as enable. This is active low, hence low, and DTR bar again low, and DN bar is also low here. So in this way, the read can be done in the maximum mode. The only one or two modification with respect to minimum are here S2 to S0 is added here, and instead of just read we are having memory read, and you can also have IO read, IO write also. Now coming to the write diagram. In write diagram, the difference you can observe, instead of memory read you are having memory write, but here we are having two types of memory write: actual memory write, IO write, and advanced memory write and advanced IO write. So generally the memory write here, it is starting here. If you observe, at this time only writing can be done, but for the speed operation if you have to do, then in advance, no, one cycle in advance you can done that by using a signal calling it as advanced memory write and advanced IO write. The remaining are all same. So with this, we have completed here the system timing diagrams both in a minimum and a maximum mode. Thank you.